They will be covering the fifth lesson in exposure and reciprocity for photography, and our topic is shutter speed. Our keywords and concepts for today's lesson are shutter, shutter speed, stop action, deliberate blur, which means intentional blur or doing it on purpose. Shutter speed numbers are a fraction of a second, another concept that shutter speeds control the amount of movement recorded in a photograph. Important that using the wrong shutter speed can actually ruin your photograph, so we need to know which ones to pick. And that big numbers mean, of course, small things. We've heard that before. Shutter speed and f-stop are the variable controls in your camera. They are set numbers or stops, and each camera and lens has some range of the possible values. These are the settings we change with each photograph to capture the desired image, our desired image, based on the light and conditions around us. So we already know how the f-stops and aperture affect our images. Today we discuss shutter speed. The shutter of your camera is a fast-moving door or curtain that controls the time that your light is actually allowed to enter your camera and expose your film. The shutter inside your camera, we don't see it move, but we can hear it open and close when we press the shutter release button on our cameras. The shutter is a very delicate mechanical part of your camera that needs to move precisely and really quickly. It's very important that we do not touch the shutter so that we don't break it. When we press the button to take a picture, your camera opens and closes the shutter, allowing the light to pass through your lens, through your set aperture, and through the shutter for a specified amount of time. This is how camera variables work together to create different exposures in photography. Let's look more closely at what the shutter speeds actually mean. We can see here in the exposure chart that the shutter speed numbers begin with 1, and the numbers themselves double roughly until we get to 1000. These numbers are often found on the body of your camera on a dial, or in newer, more automatic cameras, will show up in an LCD screen or other electronic display on the body of your camera. It is helpful to learn to recognize this particular set of numbers as the shutter speeds, so you do not get them confused with ISO or the f-stops. Not all cameras have this full range of shutter speeds, although most do, and some cameras have what we call half stops, which are the numbers that are actually between these standard stops, such as 45, 75, 750, things like that, but they're not typical on most cameras. When we look more closely at the shutter speed numbers, you can recognize this pattern, that each number as you move down from top to bottom roughly doubles from the one above it. What's interesting is that these shutter speeds are not made up. They are actual fractions of a second, so that 1 is 1 full second and 1000 is 1/1000th of a second, which follows the same rule of reciprocity, and with the most light at the top for the longest time, and the least light available at the shortest time at the bottom. Now, most cameras don't list the 1 over. It's just too big. It's too to put on the little tiny dials on your cameras. That's why we leave the 1 off of all of them. It just helps to understand what it is and know that we're only looking at the denominator of that fraction, since it's the same 1 over on all of them. When we watch these two videos, we can compare the length of time the shutter is open. The video on the left will show us a shutter that's open for 1 full second. It is set as 1 on my camera. Watch the curtain open and close for a second. Here we go. So you can see it's set at 1. My finger's pointing to. I push the button, it opens and closes, and now I advance it. I'm going to do it again. You can see it open and closes. That's 1 full second. This the video on the right is set at 1000. You'll see me point to that as well. And the shutter will open and close in 1/1000th of a second. You won't see it happen. What that means is the shutter on the right is open 1,000 times, I'm sorry, 1,000 times longer than the one on the left. So 1,000 of these ones that I'm about to show you will fit into the first one. You won't see it move, but watch the viewfinder window, the little clear rectangle at the top. You'll see a flash of black. That is the lens opening and closing. Set it 1,000. Press the button. You don't see it move. But watch the shutter. You don't see it move. That's it. That's it. Super fast.
I'm in the middle of something.
Okay, so now that we know that shutter speeds are actual lengths of time that our images are exposed, we can imagine that if our shutter is open for a really long period of time, that any movement that occurs in the scene will also get recorded. So by choosing different shutter speeds, we're able to choose how much motion is recorded in our image. Looking at this changing image of water here, you can see the little arrows pointing to the actual shutter speed. You can see how that image changes the way it's recorded based on the shutter that's there. So the faster the shutter at 800 freezes the most motion, and then when we get to 1 full second, it has the longest, blurriest motion. By choosing different shutter speeds, we can choose how much motion, like I said, is recorded in our image. Most of the time, we don't want any motion captured, so we choose our shutters to be faster in most images. Slow shutters require extra equipment, like tripods and shutter releases and remotes and things like that, and are difficult to manage that way. So let's look at some examples so that we can see the difference between a long exposure and a short exposure. So maybe we'll understand it better. This comparison of images shows the differences between a long, slow shutter of several seconds. You can see all of the different movements of this dancer on the left. You can see where he places his foot and moves. You see his arms. You see all of this recorded in this exposure. The image on the right is a split-second pose that we can't freeze with our eye and brain. So this is a much faster exposure that occurs with that movement. This is a chart of an enormous range of shutter speeds, 1/8,000th of a second at the top and 30 seconds at the bottom. Most cameras do not have this range. I mean, I'm not sure of a camera that has this full range at all, but what you can see in this range here of what is possible between 1/8,000th of a second and a full 30 seconds is where we shoot our pictures. The little bracket that I drew there on the left is between 1/1000th of a second and 1/60th of a second. That's where we can shoot without a tripod, and our cameras actually have that range. These images range in exposure from several minutes or hours, here with the star trails, to a few seconds on the right. You can see which part of the scene was not moving. So the ground and the buildings in both, and the landscape on the left, are not moving. And so the camera was stable with that. But you can also see the parts that were moving. To do this, you have to use a tripod that holds your camera still. Your hands can't hold a camera this still at all. There's no way you can stand that still because your heart beats and you breathe and things will shake. Now, on the flip side of that, these are, of course, split-second or stop-action images that our eye can't see and freeze on its own. Lots of images like this have been used by scientists and engineers to reveal how liquids and other very fast-moving objects, materials, behave in our world because our eyes can't see it. It will freeze things at different points in time so that we can actually see and reveal and understand the world around us in different ways that our eyes can't perceive because we just have limits that way, but a camera can capture it. The best stop action images are ones that a person can't hold, that you can't fake. You can't pose this way. It captures that moment, a peak of a jump, or the split second of this balloon popping, where you can see just how amazing, our world really is. This chart, lots of charts like this are all over the internet. I grabbed this one because you can see here that the first shutter speed where motion is noticeable is 1/30th of a second, or 30 on our cameras. We shoot only the settings on top, which is 1/60th and faster, or a number 60 or bigger. This will guarantee our pictures don't have any blur in them by mistake. So it's important to know that choosing a slow shutter, even though it might have enough light, you might not actually get the image you want, meaning you might just get a blurry smear of something because your picture had too much motion caught in it and you weren't equipped with a tripod. We need to understand this time portion of it so that we don't take pictures incorrectly, so there's no blur. Let's take these ideas to our actual cameras. Shutter speeds are found on the body of your camera typically. On older cameras, shutter speeds are found on this little dial. Notice that this range here is from 1 to 1,000, and 60 is red. 60 is a red to remind us that we don't want to drop below that number. It's sort of a stop sign, like, hey, remember 60 is the smallest number you want to shoot with. There's also other settings here. B, which is a setting for bulb, P for program, and A for aperture priority. Some people think that's automatic. It's not, but it's, it's sort of a half automatic setting, but A stands for aperture priority. Each of these numbers dials in and clicks in and lines up with that little white mark there closer to the inside of the camera, and that's where your camera is set. Now, newer cameras often have an LCD screen that shows all of your camera settings. We looked at this one last week. And in it, you can see here that the arrow is pointing at the shutter speed number, which is set here at a full 7 seconds, which is not a realistic shutter speed, but it's what the image I could find was. Now, the stop, of course, is 3.5. And without understanding which number is which, it's very easy for beginners to not understand what they're looking at. It's important for you to recognize on cameras like this which number is which, what numbers set, represent your f-stops, which numbers represent the amount of time or your shutter speeds. And then this little number line on the bottom where it goes from -2 to 2+, that is your light meter, and we'll talk about those next week. It's important to recognize what the numbers are and how to read your cameras, especially when you have ones that are a little bit more automatic like this, because it's going to seem like it'll do it all for you, but you can still get it wrong if you're not understanding what's going on. It's not completely automatic. Okay, so shutter speed, of course, is one of the settings we need to change for each photo we take. That's the most important thing we're leaving here. This is one of those things, f-stop and shutter speed work together, and we make decisions as photographers each time. Now, what are the big takeaways today? There's 3 concepts to remember. The first thing, that shutter speed is a measure of time. It's what it is. It's time. So the number on your camera, of course, is the denominator of the fraction of a second. So 60 is 1/60th of 1 second. You can actually see this reciprocal relationship that's in that whole exposure chart in the actual shutter speeds themselves, which is kind of cool. The second concept is that since shutter speed is the actual length of time that the image exposes, as a result, movement is captured in that exposure. We have to choose our shutter speeds based on that. So the bottom line is, it actually makes choosing the correct shutter speed the most important setting in your camera, because by choosing the wrong one, your pictures will not turn out. And it's very easy. What is the wrong one? Anything below 60. You want a number 60 or faster to make sure you won't capture blur that you don't want. You won't get blurry photographs. And of course, shutter speed is one of the 2 variables that we change for each photograph we take. And reading your camera and making choices about your settings is what gives you control over every photograph you take. Now, our next lesson next week starts to bring this a little bit more into the practical. It's talking about light meters and how the light meter in your camera is going to help you do all of this. If the numbers are overwhelming, the light meters will help you read your camera. It's super helpful if you have your camera by this next week to be able to compare the light meter lesson with your actual camera. All right, guys, good luck. Thanks so much.